Hey, hi everyone, this is Liesher. Summer is just around the corner, so all of us need to be ready for the swimming season. But do you ever really think about why some objects float? Now it's time to wonder and get answers. Let's look at this cube. He just sits on the table, and this is how its free body diagram looks. Nothing new and unusual. The cube is at rest, weight is acting down and normal force is acting up. They are balancing each other. But now let's look at the same cube floating in the water. Cube is not accelerating down, so does it mean there is vertical force but resist weight? Let's try to draw a free body diagram for this cube. As usual, weight is acting down, but that's about upward force. What contracts weight? And the answer is buoyant force. Wait. Buoyant force? Yep, buoyant force. Buoyant force is the upward force that exerted on an object wholly or partly immersed in a fluid. Let's look at this example. Still the same cube is placed in a fluid. As we know, pressure increases and an object goes deeper. If you don't believe me, keep watching and you will see the proof. So the bottom of our cube experiences greater pressure from the fluid than the top of the cube. The fluid applies more force on the bottom of the object than on the top, so this difference is where buoyant force comes from. Now when we figure out the occurrence of the buoyant force, let's look at the equation. I mentioned word pressure. Pressure actually plays a big role in the buoyant force equation, so I will start by reminding you of a couple of pressure formulas. Pressure is equals to force over area, or force equal pressure times area is the same things. Another way to see that equation is rewrite force as mass times acceleration and multiply fraction by height. So it will give us numerator is mass times acceleration times height, and denominator is area times height. So let's look at area times height. Does it give us something? Yeah, it's a volume. So now we can keep simplify our equation and get MAH on the top and V on the bottom. And now M over V is something. It's actually density. So mass over volume is density. And we can simplify our equation and rewrite it as density times A times H. And A also can be G because G is gravitational acceleration. So pressure is equal to density times G times H. Pressure and height is in direct proportional, so increasing the height or depth of the immersion will increase the value of pressure. But now let's come back to the buoyant force. Buoyant force. As I said before, buoyant force is the difference of the forces acted on the top and on the bottom of the object. But from the pressure equations, we can replace force as pressure times area. So let's do it. So pressure times area bottom minus pressure times area top. Next, our step is rewrite pressure as density times G times H. And we replace pressure in both sides of our equation. We can simplify our equation and take off area, density and G and leave inside of parentheses only heights. height bottom minus height top. And let's quickly look at this diagram. So actually h bottom minus h top will give us just height of the object. So Buoyant force now is equal A times density times G times H. And the same thing as before, A times H gives us volume. So Buoyant force is equal density times gravitational acceleration times volume. And before moving forward, I want to say one more important detail. It seems that volume in the equation is volume of the object, but actually this volume is equal to volume of displaced water. So we will mention in our equation that this volume is volume of fluid. And so here is more clear formula without any math. Let's look at our cube again. The cube is in the water, data is acting down and Buoyant force is acting up. Forces are balanced so the cube is at rest. But what if we add some mass? Weight becomes greater than Buoyant force and the cube sinks. In the opposite way, the cube loses some mass, the Buoyant force becomes greater than the weight and the cube floats. So the object floats when the Buoyant force is greater than the weight. Now you know that doesn't mean that an object floats. And one more thing what I would like to show you. Yeah, they are going to do some math again. I love math, so you need to love it as well. So let's look at the Buoyant force equation. Some of you may notice, but this equation includes multiplication of fluid density and volume. So density and volume. Density is equal to mass over volume. So density times volume is equal to mass. You see? So actually Buoyant force is fluid mass times G. It gives us weight equation of displaced fluid. I'm a genius, am I? But unfortunately one other guy discovered it before me, and his name is Archimedes. So Archimedes' principle states that the Buoyant force on an object is equal to the weight of the fluid displaced by the object, as we derived from the equation before. So when we place the object in the water, it displays some amount, and this amount of water has weight. The weight of this displaced water is equal to the Buoyant force acted on the object. Woo! That was awesome. You learned what's going on with the object and it floats. So you're absolutely ready for the swimming season. Have fun, get rest, don't worry, drink water, and see you in my next videos.
What are you talking about?